Make a scatter plot of the length of daylight by day number for Atlanta and Boston in a blank grid. And to make the graph easier, we call January 1 as day 1 and all the way up to 31st December, the day is 365. So the daylight is nothing but the time in minutes from sunrise to sunset. What is the total number of minutes that we have to just put it on this scatter plot? Okay, here we have required info. The length of daylight on 1st January it was 598 minutes. On February 1st, that is the day number is 32, that is 634, and all the way up to day number 335, which is 1st December, and it's the time is 605 minutes. Okay, so we have to enter this information in our graphic calculators here. All right, let me go back. So start from the stats, go to stat and this edit, and then if you have any info, just clear it off by highlighting those lists. You can clear and come down. So my numbers are this. I'll start with 1, enter, 32, enter, 60, enter, then 91, enter. So here we have the day numbers in the list L1. This is all for 12 months I entered, right, all the way up to 335. Now go to the second list and enter these numbers. So for 1, on day 1 it is the time is 598 minutes. So I'll type in 598, hit enter. Then next number is 634, enter, then 688. All the way I have to enter those numbers. So now in the second list we have all these numbers, 598, 634, all the way up to 605. So make sure that we entered all the numbers correctly. Now we'll have to draw a scatter plot. So how do you do that? I'll hit the second and stat plot. Make sure that you have this plot one, it is on, and there is a list L1 and list L2. L1 and L2 we have the same thing, so we are good. Hit enter. Now make sure that your plot is on, that's right. You can come down all the way, like these are the dots you are looking for. X list is L1 and Y list is L2, and that is the dot you need for your scatter plot. So just hit the graph now once you are ready. And, I'm seeing something else there, so I think I have an equation there. I'll just clear it off and then hit graph again. I don't see anything, so what do you have to do? I have to go to zoom and 9. When you hit zoom and 9, then you will see that is this calculator, it will calibrate by itself automatically, and your window is set and you have a scatter plot of all these dots. For X value 1, the Y value is 598. On the X axis there is 1 and it's going to 598, and for 32 it is 634, and all the way it reached the maximum and then came down. Okay, so this is the scatter plot. Now you have the scatter plot. Now making use of this, we have to figure out which particular regression equation fits into this. So that's what in this case we have to look for. It's a sinusoidal regression equation. So using our graphic calculator, we have to look for sinusoidal regression model. So how do you do that? Let me take a new page and go to calculator. I'll go to stats, calculator, that's CALC calc, and go down all the way. I see it over here in C. It is sine and regression, right? That's what is sinusoidal regression. Hit enter repeatedly and say calculate. These are the values we'll get. Now you have this y is equal to a times sine bx plus c plus d. So the values I'll copy now. My y is equal to, what is your a? 131.72947. I can write it as 7295. I round it to the fourth decimal. Then sine bx. B is 0.016946. So I can just write 0169. 0.0169 times x plus your c is a negative 1 point. I'll move it away. It is negative 1 point. So I can change this plus to minus. That's better, I think. I'll just do it with a minus sign. 1.3373. 1.3373. Close the parenthesis, plus d, that is 727.9935 can be written as 35 changes to 4. So this is my sinusoidal regression model. So this I have to enter in my y is equal to in this graphic calculator. Okay, so I'll do it here. Let me turn it on. All right. So this is what we have here: 131.7295 sine 0.0169x minus 1.3373, close the parenthesis, plus 727 plus 727.939 and 4, right? Everything is fine. Then hit graph. So we see that the graph is exactly connecting all the dots in your scatter plot. So this particular function, the sinusoidal regression model, gives us the complete form of the data. That is, using this information, you can find the length of daylight on any given day. See, I go to the table here, I hit the second and go to the table. On the first day it is 600.38. see, do we have that? It's 598, almost the same. Now second it is 634. Let us look at the thing on day 2. I mean 32nd day. I have to go all the way up to 32. On 32nd, we'll see, just a second. On 32nd day it is 633.84. 633.84 is that, almost 634. Did you see that? Likewise, now that's the 1st February. On 2nd, the length of daylight was 635.39. Likewise, on each and every day, all the way from day 1 to that 365th day of the year, you can find the length of the day. You can even find on which day the length of the daylight was maximum, the minimum. Now this information I'll transfer onto another calculator device, that Desmos graphic calculator online utility. See, I have all the values from 1 all the way up to 365. We have your scatter plot. I'll also enter our sinusoidal regression equation. That's how much? 131.7295. 7295 sine. We have sine here, and 0.0169, then x minus 1.3373, close the parenthesis, then plus I have 727.9994. So this is the graph we have, right? For the given values of x and y, see on the x-axis it is the number of days, and on the y-axis the daylight is in minutes. And using this graph, you can pinpoint, you can go to exactly whatever date you want to go. You can just verify. Suppose if you want on 75th day, what is my length of day, I can find out where is the maximum here. The maximum I reached once on this day, 172, I mean 172, sorry. On that particular day, the length of daylight was 859.729. Now going back to this chart, we must be able to identify which month this 172. Where does this day number lie? We can look at, see, all the way 152 days are gone up to 1st June. So to this 152, if I add 20 more days, 152 plus 20 gives me 172. That is, to that 1st June plus 20 days added, you will end up with June 21st. So on this 21st June, the length of the daylight was maximum, right? Now you are also asked to write the factored form of this regression equation. So we'll do that right away. Just I'll take out the common factor here. So we have y is equal to 131.7295, that's 9, sine the common factor, the factored form is this 0.0169 times x minus, so from this I have to take away 0.0169. So what is left? How do you do that? Using this calculator, I will divide that to 1.3373 by 0.0169 and get what? 79.1302. 79.1302. It is 79.1302. Let me double check. 79.1302. I rounded it. Right. Close this parenthesis and the square one. Then plus 727.9994. So the first one is this is the calculator form. And this bottom one is it is the factored form. And of course this equation is sinusoidal regression equation, which is giving us the information about the length of daylight for any given city. In this particular example, we looked at the city of Atlanta in the year 2015. Thank you.